Hi there, thanks for checking out this video. My name is Jason Somrak. I'm the Chief Financial Crime Consultant for Oracle. So if you hit play on this video, you're probably all too familiar with how difficult it can be to not only detect, but to discover the new patterns that criminals are throwing at us every day. And even sometimes the pattern that they've been using for 20 years can still be difficult to detect within traditional techniques. So within this video series, I'm going to walk you through how we can very quickly build a financial crime discovery notebook using our next generation financial crime and compliance studio, which is built on a graph analytics and machine learning foundation in a sandbox environment that allows you to do things like discovery, scenario creation, all in a very rapid, modern environment, but also allows you to productionize those things so that they become meaningful to your business. So this video is part one in the series. We're going to accomplish a few things. We're going to create our first notebook. We're going to load a financial crime graph. We'll build some paragraphs that give us insight as to how our data is arranged in a graph. And then we'll build our first detection paragraph where we're looking for a pattern like you're seeing on the screen now and trying to realize that pattern within our data on the graph. So what I'm scrolling through now, this is the completed graph discovery notebook, which at the end of the series, we're going to have completed this whole notebook. You'll notice as I'm scrolling through it that, there's more simple patterns, there's more complex patterns. We've applied different algorithms at certain point to uncover hidden relationships. So we have a variety of techniques in a very modular environment where we can leverage the latest and greatest technology in terms of graph analytics. So let's get started with our first notebook. So we're going to hit create within our studio environment and think of a notebook as a use case. So you can be very granular with a notebook. A notebook can be something like this is a rapid movement of funds scenario, right? And the whole notebook is only designed to look at that one specific scenario. In this instance, it's a little more broad and generic, and we're just saying we have a number of patterns that we want to look at for discovery, and we're going to contain those within one notebook. So I hit create on the last page, and now we're within our first notebook. So the first thing I need to do is create a graph that we can reference in our session. So PGX is our graph analytics engine behind FCC Studio. And so all I'm doing here is saying what I'm going to refer to the graph as within my session. So G equals the different graph properties that I'm going to pull back. I'm going to hit execute here, and I get confirmation that my graph was successfully created. I have the name of my graph. It tells me how many nodes or vertices and how many edges are within my graph. So that's great. But at this point, if we're going to run pattern detection, we need to understand what are those vertices? What are those edges within our data? So the first two paragraphs I'm going to build are sort of metrics as to what vertices exist within our data and what edges exist within our data. So in this paragraph, I'm typing select v.entity for vertex.entity, v.jurisdiction from G. So that's from the graph that we built in the previous paragraph. And I'm matching the vertices and grouping them by entity and jurisdiction. So I hit execute, and I'm instantly going to get the data pulled back from the graph. So we see that we have entity data consisting of accounts, customers, alerts. They're spread across a number of jurisdictions. You can see the power within our notebook environment of being able to easily and quickly change visualizations to make the data science more consumable for an end user. We can hide the code to accomplish the same thing. And we'll add in a title here. So that's another great thing about coding in such a modern, or not even coding, but doing discovery in such a modern environment is every single paragraph that we're creating is able to be executed individually. So you don't have to type in a large script and cross your fingers and hope at the end that you didn't have any errors or that you find an example of it. You can independently execute each line as you go and see what the output is. So it's also makes for a very collaborative environment. Okay, so the next one, again, we're creating is where we're looking at the edges or relationships that exist. So we want to select the edge.relationship and edge.type from our graph. And then you'll notice here where I'm saying match, and there's the V1 within parenthesis, and then the edge within brackets. So anytime that you specify a vertex, it's going to be surrounded by the parenthesis, and then an edge would be surrounded by a bracket. So that's a really very powerful part of PGQL, which is our graph pattern matching language, to where we can specify not only the relationship that we're looking for, but the strength and direction of relationship as well. Okay, so we'll give this a title. And while we're doing that, another really cool thing about this environment is each code paragraph that we put together here, it's instantly callable as a REST service. So you can create paragraphs that look at, risk scoring, or that would be implemented within an enterprise case management system to really enrich the user experience when they're looking at a flagged event. Okay, so we've done 3 things so far. We've created our graph. Actually, 4 things. We created our notebook. We created our graph. We've asked 2 questions. So what are our available vertices? What are available edges? And now what I did was I just pasted in a text explanation, no code at all, just the text stating of the pattern that I'm looking for. So you can imagine this could be a pattern that an investigator provides to a data scientist or a business analyst and says, hey, find us this pattern where a customer transfers money from one of his or her accounts to another of his or her accounts through an external entity. If this pattern exists, it could represent, fraudulent, or money laundering, any of those sort of behaviors. So now that we've just logically explained what we're looking for, I copied in my code here, and just in the interest of time, that's looking for this exact pattern. If you want to go ahead, you can pause the video and take a look at the code there. But it's looking at, doing the pattern matching on the vertices and the edges for that exact same pattern that we're trying to meet. So we'll go ahead and we'll give this a name. We're going to hide the code. And now we can blow this visualization up and we can start to apply some highlights on it because, doing discovery right now, we don't have any highlights on it. It's just found one version of this graph. So we need to enrich it a little bit. So the first thing we're going to do is provide some labels. So we'll give the node labels a name. We'll give the edge labels a relationship so we can see how the edges are relating between the vertices. And then we can go and start to enrich to an even deeper level. So the first thing we're going to do is we're going to add some icons to the different vertices. So if we right click on each of these, we can see the different properties that are associated. So we can see customer, account, we can see external entity. So when we apply filters, we're going to say that the entity is equal to customer. And then if that's true, we can add any number of these highlights. So we're going to say that it's a person. So we'll add a person icon if it's a customer. And there we go. Charles Summers icon just changed. Now let's do the same thing for if there's an account. So we're going to say if the entity is equal to account. We're going to add a different icon. And let's say it's going to be a folder. So now anytime we see a folder, that's referencing an account in our graph. And let's do the same thing for the external entity. So we'll say entity is equal to external entity. And let's give that, let's say a bank. Okay, perfect. And you could see how quickly and easily that you can apply icons, filters, highlights within a graph. So now let's do the same thing to the edges, because remember the pattern we're looking for is money moving from customer accounts to an external entity and back and forth. So in this one, we're going to click on the edge relationship is equal to external entity account common wire transaction. If we find that it's going to be a color red, we're going to make it animated, and let's make it dashed as well. Okay, so now you can instantly see that the transactions that are leaving the external entity coming back to our customers' accounts and back to the accounts held by our institution, those are represented in red dashed lines, and they're animated going to those folders. So we can apply the same thing now to the transactions that actually leave our customers' accounts and go to the external entity. So we'll say the relationship is equal to account external entity common wire transaction. We're going to give those a color of blue. And we'll get rid of the animation. We'll just make them dashed. And so now we can see anything in red is money leaving the external entity going to our accounts. And anything in blue is what our accounts are sending back to that external entity. We can also apply risk sort of thresholds on this. So we'll say if the risk number is greater than 6 on any vertex, let's increase the size and let's make it purple. And there we go. So we found out that both of these accounts have a risk greater than 6. So if we click on it, we can see the risk number is 7. And so you can see very, very easily how you can very quickly and easily filter and highlight within a graph to understand what the actual behavior is, what's going on after you match that very simple pattern. So that's what we were trying to accomplish today. We'll go ahead and we'll give this notebook a title. And in future weeks, what we're going to do is we're going to add a second pattern. We'll start adding algorithms to the endpoint where we'll eventually have the complete financial crime graph discovery notebook available. So hopefully you found this useful and you were able to see how easy it is to very quickly and easily not only discover patterns, but interrogate them. And hope you'll stop by for the future editions of this video. Thanks for stopping by.